welcome to the Technik Museum Speyer. I'm happy that you are here, that we could make it for a big event with you. We do a short interview. And my first question, what motivated you to apply for NASA's 10th astronaut group in 1984?
Well, you know, when I was growing up, there was not a chance for a woman to be an astronaut. There were very few astronauts at all, and none of them were going to be women. So I never thought about it as a child. But when I was working for the Army as a civilian, I saw an announcement NASA was selecting the next group, and I thought, why not? You know, there's no chance in the world they're going to pick me. So I sort of did it on a lark.
So you were selected and shortly thereafter began basic training as an astronaut candidate or ASCAN. Yeah? About 1.5 years later, on January 28, 1986, the Challenger disaster occurred. How did that affect you? Did you consider not continuing to be a future astronaut?
No, I never considered dropping out. I was at that time working in the Shuttle Avionics Integration Laboratory where we tested where we tested all the flight software. And we actually stopped a run to come out and watch that launch. And then when we saw it destruct, I thought, man, push the turnaround. Because in the simulator, you can always turn around. You can always start over. I thought, start it over, start it over, start it over. And you just can't do that in the real world.
What were your tasks as a mission specialist in the middeck during launch and in the flight deck during landing aboard Discovery on your first mission, STS-33, in November '89?
On STS-33, I was on the middeck by myself, and not much to do during launch. Just watch my watch and know, you know, we're not going back to Florida. Another time goes by. We're not going to Africa. We're going to orbit. And then when we finally got in orbit, my job was to put a lock on the side hatch. And so I unstrapped myself and I started floating around and bouncing around all the walls, you know, not being very careful. I opened the bag on my seat to get the pieces. There were 4 pieces. They floated everywhere. So I finally corralled them and moved over to the side deck and got that on. It took probably 10 times longer than it had in training because I hadn't accounted for all the floating business, which was very new.
Yeah. In weightlessness, everything is upside down or the other way around. Yeah, because typically training on Earth, you have the floor and everything above you. But in space, it depends how your direction is. Yeah.
It is, and that's a lot of fun to play with. Sometimes you can flip upside down, and after a while, your brain will decide that's down and this is up. But then you can't find anything. It's very bizarre.
Yeah. On your second and third missions, both aboard the Space Shuttle Endeavour, you were Mission Specialist 4 on STS-49 and Mission Specialist 1 on STS-61. What is the difference between 1 and 4?
It's basically where you sit for launch. So Mission Specialist 1 sits on the flight deck along with the flight engineer, the pilot, and the commander. And MS-4 is on the middeck, typically right in front of the hatch, the payload bay hatch.
And sitting on the hatch is also for an emergency, I think, this position?
Yeah, I guess it is. And I think about it, that you're the closest one to the side hatch to get out.
That's what I mean. Yeah.
And at that time, we had a pole. If we had to bail out during flight, we had a pole that extended out the side hatch. And so I think it would be my job at that time to deploy the pole if we were bailing out in flight.
Yeah. On your fourth and last mission, STS-73 aboard the Space Shuttle Columbia, you were Mission Specialist 3 and Payload Commander. What were your tasks and what were you primarily responsible for, especially as a payload commander?
The payload crew for a Spacelab mission is often assigned before the pilot and commander. And so from that point, you speak for the crew. It's kind of like being a player coach on a team. You know, no real hierarchy in that. It's just, you know, if somebody has to speak for the crew, it's you, for the payload crew.
Yeah. And I think always the payload commander was an experienced astronaut. It was typically not a rookie on his first flight. It was an experienced one on lots of missions.
That's true. And the rest of our payload crew was all rookies. In fact, Ken Bowersox, the commander, and I were the only 2 on that of 7 who had flown before on the flight.
On your first flight, you reached 8 minutes and 30 seconds after liftoff Earth orbit. Describe how you experienced the flight into space in the middeck and flight deck into space and from the ignition of the SSMEs, booster ignition liftoff, and the flight phases from SRB set to MECO. Was there a big difference in the middeck and flight deck? Middeck has no windows.
In mid-deck, you just see lockers in front of your face. That's pretty much it. There's a window in the side hatch, but it's kind of behind you. You can't see that. So there's really nothing at all to see. On the flight deck, you can see out the overhead windows, which is nice, and not so much out forward windows, you can look up a little bit, but you can't look at where the nose is pointing. So most of the view is in the overhead windows and looking out.
You have for the first few minutes daylight before it's getting dark when you get into space?
You know, I don't remember that kind of thing because we often, if we launched at night, we were heading eastward and we flew into sunrise pretty quickly. So I don't recall it going, from daylight to dark in the first few minutes of launch.
How did you experience weightlessness after reaching Earth's orbit on your first mission, STS-33, because it was the first time?
It was my first time, and you learn pretty quickly not to push off anything very hard because you'll hit the other wall very hard. So you move very gently, but I hadn't learned that yet. And so I was just bouncing around trying to control my body and where I was and finding all the pieces of that side hatch lock to put on. And so by the time I finally got that on and looked up through the hatch, out the overhead windows at the Earth, I wasn't feeling very well. I had done a lot of flips and turns, and I wasn't feeling great at that time. But the surprising thing is the Earth was so bright. That's the one thing that you can't bring that back. We can see pictures, IMAX films and stuff like that, watching the Earth go by, and that's pretty much what we see, but not the brightness of it. The brightness is just stunning.
And I think you saw a lot of blue and maybe white clouds, but mostly blue.
I guess it is mostly ocean for sure, but there's something interesting anywhere you're flying over. In the ocean, you can, with the sun glinting off of it, you can actually see the water moving around and stuff like that. The cloud formations are always interesting to look at. Now, if I were up there for 6 months on space station, I might find it less intriguing. But when you only have a few days, you want to absorb as much of it as possible.
Yeah, when you have a little spare time.
So everything was fascinating.
On shuttle missions, the timeline was pretty filled there, and there were only like every day a few minutes to looking out the window.
Especially Spacelab missions, because you're in the Spacelab that has no windows. So that's your work site for 16 hours a day. And so you don't get a lot of time to look out the window on those kind of missions.
Your second mission, STS-49, was the maiden flight of the Space Shuttle Endeavour in May 1992. What was the main objective of the mission and what were your most important tasks?
We had two objectives. One was to capture the Intelsat 6 satellite and strap a new booster motor on it. And the other was to do some demonstrations of of space station assembly. Some of the earlier concepts for space station included kind of a sticks and balls structure, like Kinects, toys that kids play with. And so we were going to do some demonstrations on that. It turns out it was a lot harder to grab the satellite than we thought. Instead of one spacewalk, that took 3 spacewalks. So we only had one that they would let us do for the space station assembly. So that was my chance to do a spacewalk on that flight.
You just mentioned that you executed your first EVA on this mission. What were the main tasks for the EVA, and can you tell me your feelings working outside of Endeavour because you wear your own satellite in the spacesuit?
It's a lot harder to control your body because when you put on that spacesuit, you've tripled or quadrupled your mass, and so you still have to control that. It's harder to work in it. It's generally pressurized higher than what we train in, and so the suit didn't bend where I wanted it to bend, and it turns out there were some switches I had trouble reaching. I couldn't get my arms any closer than this because on the front of the suit you have the display and control module. On the front of that we hang tools, and I couldn't get my arms around it, so it's a lot harder to work in that than you can imagine it being. And so the real concern to me, and I think most people, is not that I'm going to get hurt out there. It's that I might mess up or I can't do what I had signed up to do.
How was the view to the Earth during the EVA compared from inside when you have only a little window?
You actually don't get much chance to look at the Earth because your work site is down into the shuttle. And so that's, you can't just turn your head and look at Earth. You'd have to turn your entire body, to do that. So there's not a lot of chance to look out there on that. There is some, occasionally we were building this truss out of sticks and balls. So I was up on the top of one of the poles.
Yeah.
And there were some chances to look around there.
Yeah, when you turn your head inside the helmet, you only see the inside of the helmet,
That's right.
but not what we are doing like this.
That's right, yeah.
Your third mission, STS-61, aboard the Space Shuttle Endeavour in December 1993, was the first servicing mission for the Hubble Space Telescope. You performed 2 spacewalks. What was the main task of this mission, and what were your most important tasks during the EVAs? It was very different to your first EVA, where you tested a lot of things, but here you had to do a lot of repair for Hubble.
Right. The first objectives that we did in the spacewalks was for the health of the telescopes, and changing out the gyros, changing out the solar arrays. So my first spacewalk was the second one of the mission, and Tom Akers, my partner, and I changed out the solar arrays on that spacewalk. Then when we had the health of the spacecraft the satellite in fixed, then we moved into changing out the instruments. So the next spacewalk, the other team changed out the wide field and planetary camera, the instrument that sends us the gorgeous pictures. And then following that, Tom and I went out again and put in corrective optics for the rest of the instruments in the telescope. We put in this big box called CoStar. And then the last spacewalk was, we call it cats and dogs. It was everything left over. So changing out the some other electronic boxes and things like that on the last spacewalk.
The Hubble telescope had a major problem with its mirror, yeah, and this mission was very important to get Hubble back to his work, what he had to do, yeah. How difficult was it to develop the technology needed to restore Hubble to full functionality?
Well, I tell you, the real heroes of the mission are the people who figured that out. Not those of us who put wrenches on it, but the guys who figured it out. For the wide field and planetary camera, it was planned to be changed out on that mission. So the new one that went in had corrective optics built into it. So it would intercept this distorted wavefront and then send it into the camera, and there was another mirror in there that corrected it. For the other instruments that are in the bottom part of the telescope, they couldn't do that. And so we took out one of those big instruments, which is about the size of a phone booth. And in its place, we put another one. And after we left it, the ground commanded this beam to come out of the corner of it, and it had mirrors on it. And one of those little mirrors corrected the optics, and the others bounced the light into the 3 remaining scientific instruments in the bottom of the telescope. Figuring that out and making it work, it was just amazing feat of engineering.
I remember the big box on a photo when you moved that box and put it into Hubble. And I think, especially in space, there is one thing what is pretty easy compared on Earth. Everything is weightless. Yeah, you have boxes, items which weighs hundreds of kilograms or some tons. Yeah, but in space you can put it with your index finger and you move it.
It is, but the challenging part for me is I couldn't see where I was putting it. I could just see silver in front of my face, and so my job for most of that moving it was to be as rigid as possible, so that Claude Nicollier could move me and the arm, and the box as a rigid body.
Was it controlled with video cameras from the inside, from the flight deck or so, or that?
He had visual from the inside, and he also had cameras from the 4 corners of the cargo bay, and he also had cameras on the arms.
Yeah, because the astronaut who is moving the RMS, the remote manipulator system, the arm, he should figure out how to move, because, as you said, you saw only a little silver in front of you of this box.
So Claude, I think, probably mostly just used visual out the back window, and then Tom Akers actually went into the telescope, and he was giving directions from inside there to me and to Claude to pitch up or yaw or move a little bit to the left, that kind of thing. So it was that visual that Claude could see and Tom's directions is what got it in there. And I just had to be very still until it got really close to the guide rails, and I could see one guide rail on the top left corner. We were supposed to slide it in that, and there was another one bottom left that I couldn't, bottom right that I couldn't see. And so Tom was talking about this one, I could see this one, and then we could slide it in.
Your fourth and final mission, STS-73, aboard the Space Shuttle Columbia in October 1995, was a mission with the European Spacelab module. What were the main tasks during the USML United States Microgravity Laboratory mission?
We had 30 or 40 different experiments in the Space Lab, and some of the ones that were most engaging to us are the ones that we had control over. So there was one, and it sat right back there, and it was the drop physics module, where we would inject a drop of liquid into a little box about, I don't know, 6 inches on a side, and in there we could control it just with sound waves, little stereo speakers, and we could spin it up till it blew apart. We could smash it flat and then release the pressure and watch it oscillate. And what they were looking at least for some of those experiments, was the movement of surfactants, which is a molecule in the liquid that modifies the surface of the liquid but doesn't really change the bulk properties. So when you smash it flat, you create more surface area. So these little molecules have to migrate to the surface, and then you release it and they have to migrate back in. So the scientists, the principal investigators, could learn about the movement of those molecules by the vibrations and when it was relaxing and things like that. We were not scientists on it. We were just basically operating it. But it was really fun to do.
Can you describe one or two of the big challenges and what were the most exciting experiences during your 4 space shuttle missions?
Most exciting? Well, liftoff is always exciting.
EVAs? Or?
Take off, lifting off for sure, because you know you're going.
Yeah.
You know, you can slip, you can lose the mission, you can get canceled. You know, until the solid rocket boosters light, they can always take it away from you. So that's always a big one. And the EVAs were, I wouldn't say they were fun. They were challenging. They were definitely challenging. So much was riding on what we were doing out there. You have so little time, and everything, you have to get it done. And as I mentioned, the big concerns to me were, oops, what if I really can't do this? I signed up to do it. What if I can't?
When we see photos of astronauts executing an EVA, it looked very nice with the Earth and so, but it's very challenging. And I heard from NASA engineers that the astronauts lose 2 or 3 liters of water on each EVA because they have to drink also during the EVAs.
We do have water bags in the suits. I think that they've gotten bigger over the years as the EVAs have gotten more rigorous. I don't remember physically, aerobically moving, but on my first EVA, where we were trying to stow the poles from our space station experiment, in the water tank I could reach down and get it where it needed to go, and I guess I was bending the suit a little bit. But in space it was pressurized more and I couldn't bend it. And I tried so hard to do that. When I came in, I felt like I'd done 100 crunches, and my abs were really sore, more so than when I normally go to the gym and work out, because I was trying to make that suit do something it didn't want.
We are sitting here in the original Spacelab training module of the German Aerospace Center, DLR. You flew a Spacelab mission on your last USML mission. Does it bring any memories back to you?
It does. In fact, I noticed we walked in the back door. There's not a door on the real one on that side. It's that the orbiter would be that way. So the command station is right there with the computer. That was normal. That panel up there is normal. But all the experiments were changed out. They're individualized for each mission. So I don't recognize any of these experiments, but I could tell you, drop physics module was there, and there was something called another interesting one that was back there. There was a crystal growth furnace right here.
In the Apollo and Beyond exhibition, we have the Soviet space shuttle Buran OKGLI, the counterpart of the US space shuttle Enterprise. You flew 4 missions with the US space shuttle. Does seeing the Buran OKGLE, and you were inside yesterday in the middeck and flight deck, bring that back any memories for you? Because the Buran is pretty much the same as the US space shuttle.
It does, although I don't think I ever saw a space shuttle as stripped out without the lockers and things in it. So this one has none of that in it, so you can see the boxes and the cables.
And the cables,
I don't know that I ever saw any of the space shuttles in that configuration, but yeah, it looks a lot like it.
This is the first time at the Apollo and Beyond Space exhibition at the Technik Museum Speyer. What do you like best about it?
There are I've never seen so many artifacts in one place. It just goes on and on and on. you know, it would take days to read all the panels that you have up about the various missions. And it would be fun to do that, but I'd have to take it in chunks to do that because there's just so much.
Yeah. Yeah, now there are about 300 panels in German and in English, yeah, and we have about 650 artifacts, and I think 70% or so are flown, yeah. And we have a big section, the Hall of Fame of German Astronauts.
I saw that, yeah.
And this is unique in Germany, yeah, with 239 artifacts. You have visited many space museums around the world. How would you rate the Apollo and Beyond Space exhibition at the Technik Museum Speyer?
It is extensive. It's amazing, all the things that you've collected.
This afternoon you gave a lecture on your 4 space missions here at the Technik Museum Speyer. Why do you think it is important to talk about astronautical space travel and give lectures on the subject, especially for the young generation?
You know, I spent 20 years as an educator, a professor, and we think about, you know, how do we educate students for the future? But what's the future? How do we know what the future is?
Yeah.
And so I think that my best way to predict the future is to look at the past, see how far we have come in one lifetime or some period of time, and then try to project that into the future. Because that's for those kids to develop. We have nothing to do with that. We've done our part, and they're gonna make their future, and we just have to give them the tools to allow them to make their own future.
To give them the basics, yeah.
Yeah.
Kathy, thank you very much for your visit and for the interview. I appreciate that very much.
My pleasure.
Thank you very much.